multiplying polynomials can be pretty straightforward. There's two methods that you could do. I'm going to show both of them. So in this first method, I'm going to show you distribution. So that's just where you take each term in the first set of parentheses and you multiply it times each term in the second set of parentheses. When you have a binomial times a binomial, that is called foiling often. Some people also call it distribution or double distribution. All right, so when I do that, 5x times 2x is 10x squared. Notice I'm multiplying together the coefficients and then I'm adding the exponents. So these exponents both have these variables have an exponent of 1. So that's where I'm getting x squared from. And then I take 5x and I times it times 3. That's 15x. So that was 5x being distributed. So now I'm going to go through and I'm going to distribute the negative 8. When I do it, I tend to stack them because I like to put my like terms together. So negative 8 times 2x is negative 16x. And negative 8 times 3 is negative 24. And then just like we did with polynomial addition, you just add down. So in this case, I get 10x squared. 15x and negative 16x is negative 1x minus 24. Now, that distributive method is completely acceptable for a binomial times a binomial, but when you get a binomial times a trinomial, I find things can get a little messy, and sometimes it can be difficult to tell which terms you've multiplied together. So in cases like that, I often recommend what's called the box method. So with the box method, what you do is you write a polynomial that goes down the side and a polynomial that goes across the top. And then you multiply them together, okay? Remember, you multiply your coefficients, so the numbers in front, and then you add their exponents. So negative 2 times 2 times 3 is negative 6, and then x times x squared is x to the third. Negative 2 times negative 1 is a positive 2, and then I get an x squared. Negative 2x times 7 gives me a negative 14x. 4 times 3x squared is 12x squared. 4 times negative x is negative 4x. And 4 times 7 is 28. Now, if your polynomials don't have any missing terms, okay? So as long as this doesn't go from like a square to a constant, it just goes down by a degree each time, then what happens is you get this nice little pattern across the diagonals. Come on, marker tool. All right, and that pattern is really convenient for collecting your like terms. So see here how the squared terms go across a diagonal and the linear terms go across a diagonal? That works almost every single time, with the exception of if you're missing a degree, because it deletes a line from the table. So when I go to collect here, I have a negative 6x third that didn't have anything to combine. 12x squared and 2x squared combine to make 14x squared. Negative 4x and negative 14x combine to make a negative 18x. And then that 28 that's chilling there gets added on here at the end. And this is our final solution. Notice how we're keeping it in that nice standard form.